Okay, this is the second video for lesson 5.2 over discrete random variables. And now we want to move into talking a little bit more in depth about those discrete random variables. And the first thing we want to find is what is called the mean, right? Mean's pretty important value in this class. So imagine, let's go back to our problem where the teacher was looking at misspelled words in the essays. So imagine if a teacher graded 8 essays and found how many misspelled or how many spelling errors were in each essay and then got the mean. We would call this X bar. So again, imagine if she graded 8 essays and one had 0, one had 1, one had 1, another one had 2, one had 1, one had 5, one had 4, one had 0. Okay, so let's imagine she graded her 8 essays and these were the results in each of those essays. Now we would add those together and get a mean. So it'd be simply to add those together, right? So that'd be, let's see here, 1, 2, 3, 4, 5. Be 14, I believe. So 1, 2, 3, 4, 5. Another 5 is 10 and 14. So we do 14 divided by 8, and this would be 14 divided by 8 would be a mean of 1.75. Now remember, that mean of 1.75 came from just a sample of 8, so we would call that X bar. So all we're trying to say is over the course of those 8 essays, the students for those 8 essays made an average of 1.75 mistakes. But imagine the teacher were to look at a very large number of essays. This long run average is known as the expected value. It is the mean over a large amount of essays, not a specified amount. We use some different symbols for this hypothetical mean. So again, X bar is the mean of a specific sample of 8 essays. But now we want to think about the mean over the long run, not looking at 8 essays, but looking at many essays. We call this an expected value. We use 2 different symbols. It's up to you which one you want to go with. I'm going to tell you which one I prefer though, but we use the E for expected. We say, what is the expected value for X, right? This does not mean E times some value X in parentheses. No, this is just like a notation. We're saying, hey, what is the expected value for the random variable X, right? So this is basically saying when a teacher opens up an essay to read, how many errors will she expect in that essay? And that is looking at something that has come from a long amount of essays. Not just looking at one essay, but what she wants to know is what does she expect for any one essay? Now the other symbol we use here is mu with the little subscript X here. So we're saying, hey, mu is another word that represents mean, and X bar is the mean of a sample, and where mu is the mean of all, right? All essays, the long run, many essays, not just a set number. So we're saying, hey, what is the mean of our random variable X? But it's really important that you remember that subscript there so you understand that we're looking at the mean of a random variable, not the mean of some population or something like that. So again, hopefully you understand the idea that if the teacher looked at 8 essays, she can get an average number of mistakes, X bar. But now what we're trying to focus on is what does she expect for any one essay? And here we're looking into the future. Many essays, not any specified amount. And there's 2 symbols that we use for this. Now here's how to find this value. So the mean or the expected value of a discrete random variable. So first off, let's suppose that X is a discrete random variable with a probability distribution. So this is just being very generic. So we have our outcomes X, X1, X2, X3. Those are the individual outcomes, and this can go on for however many you have, ... And then under each one, we have the probabilities. This is the probability for outcome 1, the probability for outcome 2, the probability for outcome 3, and so forth. So to find the expected value or the mean of the random variable, all you have to do is multiply each possible outcome by its probability and then add all of those products together. So we take the first outcome times its probability, plus the second outcome times its probability, plus the third outcome times its probability, and we repeat this for all outcomes and all probabilities. Or a way that we could kind of shorthand this is use our summation symbols. Remember this weird looking E is the sum. So we just take the sum of each individual outcome times the probability of that individual outcome. That's what those I's are for. So if we take each individual outcome times its probability, sum all of those together, we get the expected value for that random variable. And again, there are 2 symbols here, E for the expected value of the random variable X, or we could use mu, that is the mean of that random variable. All right, but the biggest thing that a lot of kids struggle with is what is an expected value? They don't truly understand it. So I'm going to explain as many ways as I can. So go back to our essay problem with misspelled words. The expected value is when a teacher gets an essay out to start grading it. how many words does she expect that essay to have misspelled? And the idea is that she only knows the expected value from looking at the long run, looking at many, many, many essays. And well, she can't actually, maybe a teacher has looked at many, many essays over the course of his or her career. But the idea is that we want to find a way to calculate what is expected for any essay. And it's very simple to do, as I just showed you. All you need to know is your outcomes and your probabilities. Okay? This is actually kind of similar to LeBron James' scoring average, right? LeBron James' scoring average is 28.4 points per game. He'll never actually score 28.4 points per game. It's literally impossible for one player to score 28.4 points in a game. You could score 28, you could score 29, you can't score 28.4. And that's okay. This is his expected value, right? This is what he has found after playing many, many, many games. So when LeBron James steps onto a court for any single game, he expects to score 28.4 points because that is what he has done consistently over time. It's the same thing. When a teacher steps into her classroom to grade that essay, what does she expect? What does she expect the number of misspelled words to be? And that's where we get this idea of an expected value. It's an average in the long run for what we would expect on any given essay, or for LeBron James, any given basketball game. Now, of course, he could score more or score less. We'll talk about how this could vary in a moment, but I want to get the idea of what's an expected value. Now, always use proper notation for an expected value. Please, 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 I can't emphasize this enough. The AP loves using proper notation. So you could say, hey, the expected value for the random variable is, you can use that notation, or another way is saying the expected value for a random variable is, and using the notation with mu. Now, I prefer this. This is just me. That's what I prefer. It just makes sense to me because I understand that X bar is the mean of a sample, whereas mu is the mean, a theoretical mean over a long series of trials. That's kind of how I think about that, okay? Also, please understand that non-integer values do make sense as a mean in the long run. Yes, LeBron James can never score 28.4 points, but when you're talking about an average in the long run, it does make sense to have a decimal there. So go back to our teacher problem here. We got an average of 1.75 from the sample. Well, you could never have 1.75 misspelled words, but that's not what we're trying to talk about here. We're trying to talk about an expected value, so decimals are okay. All right, so let's actually go ahead and do an example here to figure this out so we can see how this is actually done. So here's our problem, right? A high school teacher has 500 word, turns in a 500-word essay. She's going to grade it. Teacher's going to grade it. X is how many misspelled words there could be. So to calculate the expected value here, and again, you could use either notation. For a while, I'm going to use both notations. The expected outcome for X, or the expected, again, when you say it, it's the exact same thing, the expected outcome for X, right? The mean in the long run. You could use either phrase, the expected value for X or the mean in the long run, and that's where we kind of get these two different symbols here that mean the same thing. So to calculate this, it's so simple. I'm just going to open up my calculator here. I'm going to take the first outcome of 0 times its probability, plus the second outcome of 1 times its probability, plus the third outcome of 2 times its probability, and I'm just going to kind of shut up now and start typing. Now, it's so easy to type something in by mistake. So, you forget a plus sign, you hit 2 plus signs and something like that. So just be very careful. 0 times 0.15, 1 times 0.25, 2 times 0.40, 3 times 0.10, 4 times 0.07, 5 times 0.03. Now, this is another reason why I like classic mode real quick, because classic mode, it kind of shoots it down the line so I could still see everything I typed in. Whereas when you go to math print mode on your calculator, it starts putting into a line where what you typed in the beginning kind of disappears and you got to backtrack to go see it. I like to see everything I type in, which is why I like classic. And hit enter, and here we go, 1.78. So 1.78 words misspelled is the mean in the long run. All right, now no essay is ever going to have 1.78 words. That's okay. It's the idea that when I, as a teacher, grade an essay, when I look at any one essay, I expect 1.78 words to be misspelled because I know that that is what's kind of known to happen here with these kids, right? And it makes sense. This should be very, very easy to understand. It is what we expect in the long run. So if I were to grade many, many, many essays, not 1, not 5, not 8, not 20, not 100, many, many essays, over the course of grading all those essays, I would expect an average of 1.78 misspelled words per essay. That's exactly what this value represents. Very, very simple to find. All right, but every expected value varies a little bit, right? Not every essay is going to have that value. It could be a little higher, could be a little bit lower. Compare this to LeBron James, right? He's supposed to score 28.4 points a game, but, how many points he scores a game varies. Sometimes he might score 50, sometimes he might score 11. The idea is that how much you expect something, but it's still going to vary a little bit. So it's no surprise that with a mean comes a standard deviation. How far a typical outcome will vary from that mean is your standard deviation. Again, how far a typical outcome will vary from the mean. And we know that the further you get from the mean, the less likely that is. So if LeBron James scores 28.4 points a game, 50 points, 60 points, 70 points, I guess with LeBron is always possible, but more unlikely. Same thing in the other direction. He's so good that he really rarely ever scores 5 or 10 points a game. So the closer you are is more likely. So, 26 to 30 points, that's pretty likely because that shows how good he is. All right, so how do you find standard deviation of a mean, right? Well, first we have to find the variance. If you go all the way back to when we learned about standard deviation, you always have to find variance first and then square root that total variance to get standard deviation. So here's exactly how we do that in a kind of a generic mindset here. So once again, we have x as our discrete random variable, where we have outcome 1 times the probability, outcome 2 with its probability, outcome 3 with its probability, and ... if there's more outcomes and more probabilities. So the first thing you have to do is find the variance. To find the variance, which we can denote VAR, that's for variance, the variance of the random variable, or another symbol we use is sigma, right? Sigma squared. So the standard deviation is sigma, and then squaring it is where we get variance. So the formula here is you take each outcome minus the mean, square that, times it by its probability. Take the next outcome minus the mean, squared, times its probability. Next outcome minus the mean, squared, times its probability. And you repeat this over and over. And then you add up all of those square deviations. So a way that we can shorten this is to use our sum symbol here. So the sum of each outcome times each outcome minus its mean, squared, times the probability of that outcome. Then, remember, this is only variance, which is standard deviation squared, right? Variance is standard deviation squared. So variance, I'm going to write this down because this is going to be important for later, is standard deviation squared. So the formula for standard deviation would be to square root that sum of all that square deviations. So the symbol we use here is, some people like to use the standard deviation of the random variable x, or we could use sigma, which is our symbol for the standard deviation in the long run. So the standard deviation of our random variable. Now the formula here would be a square root of all that variance, okay? So again, very, very tricky, very, very kind of ugly formula. It definitely takes some time to figure out. So, what is the standard deviation of a random variable? The standard deviation of a random variable x is a measure of how much the outcomes of the variable vary from the mean. It's just like standard deviation, how far a typical value is from the mean. It's the same thing we're doing here. The standard deviation is how far a typical random variable outcome will vary from that mean. Now the formula for the mean is very easy to do. I mean, multiply, 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 and add. The formula for mean is very easy, as I showed you on the calculator. But the variance and standard deviation can be a little bit taxing and time consuming, so we will rely on our calculator for the most part. All right, so let's actually find the standard deviation here. Now the first thing we have to do is we have to remember the mean. The mean of this random variable, if you recall, was 1.78 misspelled words. And hopefully you remember how we found that. It was just a couple moments ago. So to find the standard deviation, what I have to do, and again, this takes considerable amount of time, but what I have to do is I have to take a parenthesis, and I have to take my first outcome of 0 minus the mean of 1.78. I have to square that outcome, and then I have to multiply it by its probability, which was 0.15. And that's just for the first outcome. Then I have to add, now the second outcome, 1 minus the mean, 1.78, quantity squared, times its probability, 0.25. I have to repeat this for each outcome, which takes a lot of time to type in. That means there's a lot more room for error in typing things in. And then when I'm done with all of that, once I get my final answer of all this variance, I have to take a square root to get my final answer. But what I'm about to show you is that I would never, nor will the AP ever expect you to do all that work by hand. We're going to show you how to do this on the calculator. So easy. So to get the standard deviation in an instant on your calculator, here's how you do it. The first thing you have to do is you got to type this into your calculator. So we're going to go Stat, Edit, Edit. So Stat, and then under the Edit menu, click Edit. Now we need two lists, one for the outcomes, 0, 1, 2, 3, 4, 5, one for the probabilities, 0.15, 0.25, 0.40, 0.10, 0.07, 0.03. So you're going to notice here I use list 1 and list 2. You could use list 3 and list 4. You can actually use any two lists you want, but I prefer to use list 1 and list 2. So go ahead and take a second, pause the video if you need to, and type these values into your calculator. List 1 is the outcomes. Next to each outcome, please make sure you have the appropriate probability. Double check that you typed everything in right. Now, once that is done, here's what we're going to do. Stat, slide over to Calc, and go to one variable stats, because we only have one variable. How many misspelled words can there be? But watch the change. So under lists, we're going to hit list 1. List 1 is where our options are, 0, 1, 2, 3, 4, 5. But now we have to tell it the frequency list. Up until now, we've always left this blank. But now, not only do we have our outcomes, but we have the associated probabilities. So now we're going to tell it second list 2. So now we're going to tell it, look at list 2 for the probabilities of each outcome in list 1. Now, anytime that you're looking only at one set of data, please make sure that the frequency list is left blank. But here, because we're looking at two lists, not only are we looking at the outcomes, but their probabilities, that's what we have to add in the frequency list. The frequency means how often do those values occur, which is what the probability is. And then I'm going to hit calculate. And I want you to notice two things. First, it found the mean for us as well, 1.78. So you could actually use this feature of your calculator not only to calculate standard deviation, but to also calculate the mean. The only thing I hate about the calculator is that it calls it X bar. Please make sure you use the proper symbol. X bar is the symbol for a mean of a single sample of, say, 8 essays. Well, we're not doing that. We're looking at the expected value in the long run. The calculator doesn't know any better, so it calls it X bar. But please make sure you use the proper symbol, either our E with the X in parentheses next to it, or use the mu. Please, I'm begging you to see that and understand that. However, the standard deviation is marked as sigma. Notice the standard deviation S is left blank because this is not a sample, and the calculator knows that. This is the standard deviation, so it does it all for you. It even does the square rooting for you. You don't have to do any work. The standard deviation is 1.2048. I'm going to use 4 decimals there just for fun, 1.2048. So the standard deviation of our random variable X is 1.2048 words, okay? And all that tells me is that for any essay, put an essay in front of me, I expect 1.78 misspelled words, but that number could deviate. The standard deviation is 1.2048. All right, here's the instructions for how to do that on the calculator. So if you didn't follow along, you could go ahead and actually have it typed out here. So stat, edit, edit, enter the outcomes in list 1, the probabilities in list 2. Stat calc, slide over to one variable stats and choose list 1 for the outcomes, and then for the frequency list you would put in the probability list there, which for us was list 2. And the cool thing is this will do both the mean and standard deviation for you. So the formulas that I showed you earlier in this video you really don't even need, especially if you have the calculator. All right, the one thing that kids make mistakes with is they have no problem finding the mean and standard deviation because they know the calculator makes it easy, but they never interpret them. So please make sure you interpret them in context, okay? It's the number we expect in the long run. Please make sure that makes sense. All right, let's try this last one on our own. So the probability distribution below is for X. How many trips to the grocery store Andrea makes in a week? So in a week, Andrea either makes 0, 1, 2, or 3 trips to the grocery store. This is discrete because she cannot make 1.4 trips in a week. And the probabilities are there as well. All the probabilities there do add up to 1. So this is a valid probability distribution. And why don't you go ahead and use your calculator to calculate and interpret the mean and standard deviation. Hit pause if you want, because I'm going to go ahead and do it now. So stat, edit, go to list 1. We're going to go ahead and hit up to highlight L1, hit clear down. Let's do the same thing. Highlight L2, clear down. Don't ever hit the delete button there. So 0, 1, 2, and 3 are the options for how many times Andrea goes to the store in a week. 0.02 for 0 trips, 0.35 for 1 trip, 0.56 for 2 trips, 0.07 for 3 trips. Just double check that you typed all those in correctly. Once you're done with that, stat, slide over to calc, one variable stats, make sure list 1 is the list, that is where I put this. The frequency list was the probabilities, which I did put in list 2. Now I'm going to hit calculate, and the average is 1.68, and the standard deviation is 0.63. So notice this proper symbols I'm going to use here are the expected outcome. The mean in the long run was 1.68 trips to the store. And the standard deviation was, I'm going to go back and check, was 0.63, 0.63. So 0.63 trips. Okay. Now, please make sure you listen to me as I describe the interpretation here. Most kids say, well, you can't make 1.68 trips to the store. I realize that. This is an expected value in the long run. So after many, many, many trips to the store, Andrew would expect an average of 1.6 trips per week. There's your interpretation. After many, many trips to the store, Andrew would expect 1.68 trips per week. But that number could vary a little bit, and the standard deviation for how many trips to the store it could vary by is 0.63. So we expect her to make 1.68 trips per week, but it could deviate. A typical week could be off by 0.63 trips to the store. So hopefully you understand how I found those values and where I got them from. Now, just so you're aware, the two other notations you could use are the expected value for x, which would again be 1.68, or you could also use the standard deviation for x, which would be 0.63. However, I do prefer to use these values right here because those are what we're going to see most often in the future, mu and sigma, the mean and standard deviation in the long run, not for a sample.